Based on the visible mass of a galaxy, we can calculate exactly how much gravity it generates. But when we measure the actual rotation speeds of these massive structures, a massive problem emerges. They are spinning so fast that gravity cannot hold them together. The stars at the outer edges should physically rip away into the void, yet they stay intact. When astronomers observe a vibrant spiral galaxy like this one, the equation doesn't balance. The visible mass of stars, gas, and dust simply doesn't generate enough gravitational pull to keep the system from flying apart. To solve the math, there has to be something else out there, an invisible substance spread throughout the galaxy acting as a cosmic glue. It has mass, and therefore gravity, but it completely ignores light. It neither absorbs it, reflects it, nor emits it. Researchers call this elusive material dark matter. We know it exists because of the gravitational force it exerts on visible objects, yet we have no idea what it is actually made of. Exploring a universe built largely on an invisible foundation requires us to look closely at the resilience of the people uncovering it. A common public assumption is that dark matter isn't a physical reality at all. People often suggest it is a stubborn math error, an idea scientists stubbornly refuse to let go of to avoid rethinking gravity. Cosmologist Katie Mack, a researcher at the Perimeter Institute for Theoretical Physics, spends her days sleuthing out dark matter's true identity. She notes that this public assumption couldn't be further from the reality of her daily work. Scientists actively compare multiple mathematical models against raw data, explaining phenomena from every angle, and testing entirely new ideas. If a theory doesn't fit observational data, it's brutally discarded. Physicists win Nobel Prizes by proving exactly how our current understanding falls short. To properly investigate this invisible ghost, we have to completely dismantle the media stereotype of how scientists think, operate, and even how they grow up. Many kids grow up believing that scientists are an elite class of untouchable, superhuman geniuses. The reality is that the foundation for cosmological discovery usually begins with basic, unstructured childhood curiosity. Long before Katie Mack was tracking invisible mass across the cosmos, she was a kid building solar-powered cars out of Legos and taking apart everyday technology. She routinely dismantled TV remotes just to systematically figure out their inner mechanics. She also saw how science operated in the real world through her family. Her mother did clinical research on cancer treatments, and her grandfather served as a meteorologist in the Navy. His job was calculating weather patterns to ensure a safe, storm-free ocean splashdown for the Apollo 11 astronauts returning from the moon. But the true catalyst arrived when she was 10 years old. She picked up A Brief History of Time by physicist Stephen Hawking. His explanations of black holes and the Big Bang immediately shifted her focus from terrestrial machines to the mechanical rules of the universe itself. Top-tier researchers are rarely born with all the answers. They are simply tinkerers who choose to scale up their curiosity until it encompasses the cosmos. The idealized portrayal of a scientist in movies usually skips over the grueling reality of the academic career path. Loving the universe is entirely different from surviving the physics profession. This chart visualizes the extreme bottleneck facing young physicists. When academic research positions open up, specifically postdoctoral fellowships, there are frequently up to 300 highly qualified applicants fighting for a single slot. Progressing to a permanent faculty position at a university is even rarer. The vast majority of people who earn PhDs in physics will never secure a faculty job, forcing them to pivot their entire career plan to an alternate field when the academic route fails. For those who do secure positions, the physical and emotional toll is immense. The job demands constant international relocation. Mack herself moved from Australia to England and then to Canada. Starting over in new countries means leaving support networks behind, resulting in deep, compounding personal isolation. It takes an incredibly high level of intelligence to run the advanced mathematics of cosmology, but it requires an equal amount of emotional resilience to survive the career path required to do it. Why do researchers willingly subject themselves to geographic isolation and nearly impossible career odds, all to study a substance they can't even see? Because uncovering the true identity of dark matter is the only way we will ever accurately piece together the timeline of our reality. Without understanding the invisible material holding everything together, we cannot fully grasp how galaxies form, how they evolve over billions of years, or how the universe will ultimately end. Mack frequently tells younger students that struggling intensely with a concept does not mean they aren't cut out for the field. By definition, scientific exploration is supposed to be difficult. If it came easily, it wouldn't be new. And to handle that difficulty, researchers have to stay grounded in the physical world. During the pandemic, when the academic grind paused, Mack applied her systematic curiosity to something highly tangible. She earned her pilot certificate to fly small airplanes. The scientific community thrives specifically because it is populated by diverse, adaptable individuals. They are people willing to endure the hard work of exploration, both in the sky and on a chalkboard. Dark matter's true identity remains unsolved. There is no single stroke of genius that will suddenly illuminate the invisible universe. Progress relies entirely on daily, incremental perseverance. The invisible forces holding the cosmos together are directly mirrored by the human curiosity and tenacity driving the researchers who study them. Our understanding of the universe is constantly expanding, and so is our pursuit of its greatest mysteries. To keep exploring these anomalies and the people working to solve them, hit the subscribe button and join us for the next video.